welcome back everyone to the brand new episode of the Code Drop. And today we're going to go with an application of Stack, and more specifically, it's going to be how to convert an infix expression to a postfix expression using C. Now, I was actually going to do all the applications of data structures later when I was done with data structures, but a few people suggested me that I should do the applications just after the data structure I'm dealing with. So here's that, and that's why we're going to go with an infix to postfix expression right in this video, just after the stacks video. So first of all, we'll see how to convert an infix expression to a postfix one using paper and pen, and then we'll write a program for that. So first of all, I'll open an Excel workbook right here so that it's easier to keep track of, because making tables in Excel is relatively easy. We have already got table. We're going to see one example. It's going to be a plus b. It's going to be an easy one. So we are going to convert it in, let's go with an postfix expression. So the final output for this is going to be ab plus. How do I get there? We'll see that right now. To convert an infix expression to a postfix one, we need three columns. So first column is going to be current element. The second column is going to be stack, and the third column is going to be postfix expression. So let's do that. Let's make all three columns right here. And what I'm going to do is we're going to pass all our elements and we're going to process all of them. So first of all, we're going to process A. Let me just write A here. And now we're going to check if the element is an alphabet or an digit. So it's an alphabet or a number to be rather. And and you know that A is alphabet. So if the current element is an alphabet, what we're going to do is we're going to shift it to the postfix expression and our stack remains empty. So let me just write it here. If is alpha or is digit, then push to postfix right here. And let's go with plus then. So we got plus right now, and let me add these brackets or it won't work because it's Excel, and if you write plus, it's going to convert it into an expression. Now we've got a plus, and is plus an alphabet? No, it's not. So it's going to the stack. Let's add it to the stack here, and then our postfix expression remains same. It's going to be A only. Now then we got B, and is B an alphabet? No. So let's add plus in stack, and let's add B in our postfix expression. So it's going to become AB. Now what I'm going to do is I'm going to pop out all the elements in the stack, whatever are remaining, to the postfix expression. So in this case we only have one plus left. So let's just leave this column empty because we don't have anything, and let's write AB plus. So whatever we had in stack, we pushed it to postfix expression, so it becomes AB plus. So plus comes from stack and goes in our postfix expression. Okay, and let me just copy this and paste it, and let's make it if not is alpha digit or is digit, then push it to stack, and after all the elements are processed, pop elements from stack and push them to postfix. Okay, so it's going out of bounds here. Well, let's take another example, and let's take a little bit hard one this time. And this time we're going to see how computer looks at these problems. So what I'm going to do is I'm going to take, let's change this expression, let's make it A plus B, and after that we'll have minus, let's say, okay, so let's go with A plus B minus C. So this is going to be relatively hard one because okay, so this is relatively different than what we've already dealt with. And the postfix expression for that, I don't know. Let's calculate. Let's see what it is. So first of all, we've got opening braces. So let's just push it to stack because it's not an alphabet. Let me just delete all of these first. Let me just delete so we don't get confused. Now we're dealing with how the program, how the computer looks at it. So we've got a stack and an empty postfix expression. After that we've got a. A is an alphabet, so it get pushed to postfix expression. Now we got plus, so let's just add a plus right here, and it's going to go with stack because it's not an postfix, it's not an alphabet. And let's push our postfix expression a. Then we've got another starting bracket. So when we're dealing with this, the starting brackets really come in handy. We'll see now why. So what I'm gonna do is let's just add this also. So now we got small bracket plus small bracket in our stack, and the postfix expression is still going to be a. Now we've got b, so our stack remains same this time, and we push a b in our postfix expression. Well, next we've got minus, so let's add a minus sign right here, and it's going to get pushed to stack a plus alphabet and minus, and our postfix expression remains same. And then we got c. Okay, so it's not current element but it's just c, and it does not get pushed to stack because it's an alphabet, and our postfix expression becomes a b c. Now here's where our empty ending brackets come in handy. So once a computer encounters an empty bracket, what it does is it pops out every element until the starting bracket to the postfix expression. So let's do that. Let's see what we have right here. We've got a minus sign before our starting bracket. So our current stack becomes small bracket and plus, and our postfix expression becomes ABC minus. Again, if encountered another closing bracket, because we've got two closing brackets right there, and again we're going to pop out plus from here, so it's going to make the stack empty, and our final expression will be ABC minus plus. So this will be our postfix expression. Let's write it on top here, ABC minus plus, and let's just verify once using board mass, obviously. So we knew that using board mass we're going to first calculate b minus c because it's in bracket, and here also we've got bc, which are the two elements which will be operated on with a minus. So it's going to be b minus c first, and then we'll have a resultant. Let's just do that. Let's just assume that the resultant of bc is going to be minus c is going to be d. So once we process our first step, it's going to be a plus d, which is our answer, and in postfix it's going to be ad plus. Let me just make it ad plus. And once we do that, we've got just an e. Again, it's just an example, so it's going to be our output. Now this is how it should work, and in computers that's why we use small brackets every time we give input, so that a computer can know when to stop popping elements out. This is how infix to postfix works, and let's jump into a program. I'm not saving it. I'll just let's just jump right into a program right here, and let's see how to do that in C programming language. Okay, so let's start with our programming, and first of all we're going to include our header files. So let's start with our include statements. Now we're going to include std.h for our basic operations, and then we need include std.live.h. It's for making our exit functions work, and I'll add comments later. Let's then add include string.h because we're going to work with strings, so string.h, and I'll include ctype.h in end because it's going to help us in let's just say checking if it's a digit or it's an alphabet. So it's going to help with that. ctype.h. Now, first of all, let's define a size of, let's say, 100, and let's make it capital size ZE. It's just some thing you need to do. It's not recommended, it's not required to make it capitals, it's just the way everyone does it. So, after that, we need two variables. The first is going to be an array. It's going to be called stack, and it will have size of size, and will have an int top equals -1 to keep track of our positions. Let's jump right into our program, and first thing we're going to do is we're going to do the main function, and then we'll drop back to our infix to postfix functions and everything else. So in our main function, what we need is we need two arrays. First is going to be called infix, and it will have the size of size, and postfix, it will also have the size of size, sorry, not 100, size. Now we're going to print our first statement, which is going to be slash n enter infix expression. So let's take an input for that, and after that we're going to use gets. Well, gets is something which we do to take input for string, and that's why we included string.h. So let's take input for infix, and after that we'll call our infix to postfix expression function. So infix to postfix, let's make this also capital so it's a camel case, and infix to postfix for infix to postfix. So infix to postfix function will have our parameters as infix array and the postfix array. Okay, so let's start our infix to postfix function. Infix to postfix function right here. Now the parameters we passed is again going to be the same. Let's just say infix, and it'll have size of blank because it's going to take the size from main function itself, and again a postfix which will don't have a size. We actually don't put in size when we call the functions because it won't work. It's just not the way it's supposed to work. It just needs the name of the array or the name of the variable, and it fetches the size from the initialized part. So if I just call infix, let's say postfix without a size, it goes to main, it sees the postfix array, and then it goes to get the size from here, from the part where it's initialized. So that's why we don't need to pass size in our functions parameters. Now let's start with defining two variables, int I and j, and let's initialize them at 0. So int I is equal to 0 and j is equal to 0. After this, we're going to make an char item, or it's going to be the current item as we discussed in our Excel workbook. And again, we're going to have one more character which is going to be x, and it will just be for processing things. And processing things is what this x is going to do. Okay, the first thing we're going to do is we're going to push an element, a starting bracket, in our stack. As we discussed earlier, that a computer needs to know when to stop, and it stops when it encounters an starting bracket. So we're going to push it, and at end of the string, end of the push infix string, we're going to add an ending bracket. So we're going to use strcat. It's used for concatenating strings, and we're going to concatenate infix with our ending bracket. Let's do that. And now once we do this, once we do these two things, let's just see what happens. So if I've inputted a plus b, after the two steps it becomes a plus b within the bracket, so it's easier for computer to know when to stop. Now the final thing we want to do is we want to set item, or actually item equals to infix of I. So it's going to be item equals, let me just comment it out, item equals infix of 0 or the first element we have in our infix expression. Now we're going to start with our while loop, and this is the main loop where all our conversion takes place. So while item not equals to null, so we're going to continue our while loop until we reach the end of loop, or until we have our current item equals null, which means we have we've reached the end of our expression. So while this happens, we're first going to check if item equals starting brace. If it's a starting brace, we need to push that item in the stack. So let's just push it in stack. So I'm going to push item, and after that what we're going to do is we're going to check if our item is a digit or alphabet or not. So else, let's make it else if is digit of item or is alpha of item. So this is going to return a boolean value 1 or 0. So if it's 1 or 0, what's going to happen is that we're going to put it in our postfix expression. So postfix of j will equal to item, and then we're going to increase the value of postfix because we want the next element we filled in the second place. So let me just show it. So what happens is if we've got an a as input, then our postfix of 0 becomes a, sorry, it becomes a, and once we have done it a, we need to place our second element in postfix of 1. That's why we're doing the j plus plus. After that we're going to check if our item is an operator or not. So is operator. Now keep in mind that C type does not has an is operator function. We'll have to write that. So if is operator, it's going to be else if, sorry, else if is operator item equals to 1, which means that it's returning true, then first of all I'm going to pop x out of there. So what I'm going to do is I'm going to pop the top element from the stack and put it in x, and then I'm going to start another while loop. While is operator of x equals 1. So while it's an operator and it has got a precedence which is higher than precedence of y. Oh, sorry, not y, it's going to be item, our current item. So if this is the condition, then we're going to store x in our postfix expression. So postfix of j will become x, and then we're going to say j plus plus, and then again we're going to say x equals pop function. So this is where our magic happens, where we push our operators from stack to our postfix expression, and I will see you what we are doing here once we deal with precedence, because it is something I didn't discuss precedence while I was explaining in the Excel workbook, because we didn't actually deal with precedence. So let's move forward for now, and once the while loop ends, we're going to push x back in our stack. So why we're doing this is because we're actually popping out first, popping element. Let's make it element, and then we're pushing it in postfix. So putting in postfix and popping again. So what we're gonna do is we have popped an extra element, and we need to consider that, and that's why we need to push the element which is at end, back to our stack. Now once we push the stack, we also need to push the item, because item was the thing which we came here for, the current item. It should be pushed back in stack too. So this was else if, and again this is going to the final else if. Let me guarantee you that, because else if we're going to check if item equals to end braces or not. So you know that we have, when we have encountered an end brace, we're going to pop out elements till we've got our starting brace. So let's say x equals pop function right here, and then while x not equals to our starting brace, we're going to pop out elements. So let's store postfix of j equals to x and j plus plus, and again x equals pop function. So this is it, I guess. So we've done our popping out, and what we're doing is we have completed our operation on stack, right? So we've ended that, and we're just going to add one more else right here, and we're writing an else because if it's not a symbol and if it's not an operator, then our infix expression is not valid, so it should be printing that. So let's print invalid infix expression, and if this is the case, we'll exit the program with exit status 1. Now this was our while loop. This is where our while loop ends, and now we're going to check if top is greater than 0 or not. It's for pushing in stack. So if top is greater than top is greater than 0, then we're going to print again that it's an invalid infix expression, and again we're going to exit the program. So let me just delete it from here, it's not required. And again we're going to exit the program with exit status 1, and at the end we're going to say postfix of j will equal to null, because we want to add null to our end of string so that the program knows when to stop printing, or else it will print on garbage values. So this was our Infix to Postfix Expression. It was long, no offense, but yeah, it's done now. Whew. So we've done our hard part, and let's jump on to easy part. So first of all, we need a push and pop function, and I will just copy push and pop function from my previous video, source code from a previous video, so that it saves us time. And if you want to know how the push and pop function works, I recommend you going back to my video and checking that out so that you know how push and pop function works. Let me just remove the comments for now. These comments will be available when you download the code from GitHub. Okay, so we've got our push and pop functions, and there are two things more left to do. The first is making a function is operator, and then we have to make an function precedence. So first of all, let's make our int is operator, and we're going to pass an character sim in this. So sim for symbol or operator, you can use any other name, it's just a variable name, nothing offensive. So let's go with if sim equals to exponent, all right, or sim equals, let's say multiply, and now I'll copy this because I don't want to repeat this every time. So I need to keep it sim not sin, and I'll have to do that. So if sim equals multiply, if sim equals divide, we're just following the precedence order here, nothing else. If sim equals add, and if sim equals subtract. So if sim equals any of this, we're going to say return 1, else return 0. Okay, let's make it return 0. So its operator does not require anything else than that, and this is it. And at last we've got our end precedence function, So what we do in precedence is, again, we pass a character sim with us, and what we're going to do is we're going to check the precedence of our operator. So if sim equals exponent, it's going to return 3, which means it has the highest precedence. So let me just put it right here, highest precedence, and else if we know that multiplication and division have same precedence. So if symbol, or sorry, it's sim equals, let's say, multiplication, or sim equals division, then we're going to return 2. So let's return 2 right here. And else if sim equals add, or sim equals subtract, we're going to return 1. Okay, and at the end we're going to return 0, because we're dealing with braces also, and braces also need to have some precedence, or they're going to come in the middle of our program. Now let's jump back right in our main function, and let's add our printf statements, because we need to print our postfix expression too. So let's add a /n, and our postfix expression is going to be, let me just add an apostrophe here, and I'm going to use puts function to print my postfix expression. Alright, our program's completed now. Let's just return 0, and let's save it. Oh, sorry, I put my apostrophe something else. So let's return 0 and save, and let's run the program. Well, okay, yeah, I need to make it sim. I forgot to do that. So let's make it sim everywhere. Let's compile and see if we're getting any output right here. So in my previous videos, I've seen that the font in terminal is not visible at all, so that's why I've increased the font size here, so that it's easy to see the output. So let me just enter a plus b. Like we discussed, it should have an output of ab plus, so we're getting that. Our postfix expression is ab plus, and we're going to check if let's just compile it again. And now we're just going to say if my calculations were right in the beginning, where we discussed that a plus b minus c should give us an postfix expression of a p c minus plus, so a plus b minus c. Now we get a postfix expression of abc minus plus. It means that I calculated correctly and our program too is working correctly. So this is how you convert infix expressions to postfix ones using stacks. Alright, and that's it for today, guys, and I'll provide the source code in the description so you can check it from there and see if you can make it work or not. And thumbs up if you liked the video, and subscribe to the channel if you loved it. I'll see you on the next episode of the Code Drop. Bye for now.